I sent Bigfoot hair to a DNA lab. Here's what came back.
Today I'm going to tell you about Bigfoot laboratory and the biological location. So before starting this video, like this video, subscribe to my channel. Let's dive into the video.
What if one of North America's most famous mysteries isn't just a legend, but a real biological question hiding right in front of us? For years, people have reported seeing Bigfoot, a massive, ape-like figure slipping through forests and disappearing before anyone can get a clear shot. We've got footprints, blurry photos, eyewitness stories, and maybe most intriguing of all, hair samples that people claim came from the creature. That's where things get interesting. Hair might seem simple, but in biology, it's actually a goldmine of information. It can reveal what species an animal belongs to, confirm whether it's a mammal, and sometimes even hint at where it came from. So naturally, if someone truly found Bigfoot hair, DNA testing should give a clear answer, right? That was the thinking. So I tracked down a sample labeled as Bigfoot hair, sent it off to a DNA lab, and waited to see what science would say. The result? Not quite what I expected. Before diving into the lab results, it helps to understand the sample itself. Bigfoot hair almost always comes with a story, found snagged on a branch, caught on a fence, or left near mysterious tracks. But here's the catch: hair alone isn't proof of anything. Animals shed constantly. Deer, bears, cows, dogs, even humans. Something that looks unusual can still come from a very ordinary source. Still, hair has real value in investigations like this. If the root is intact, it may contain DNA. Even without the root, mitochondrial DNA, often easier to recover, can still help identify the species. So the goal here wasn't to prove Bigfoot exists. It was much simpler: figure out what this hair actually came from. This is where the science starts to shine. DNA testing sounds straightforward in theory. Run a test, get an answer, but in reality, it's a bit messy. DNA breaks down over time due to heat, moisture, sunlight, and microbes. Samples can be contaminated just by being handled. And if the hair lacks a root, there may be little to no nuclear DNA to analyze. Even with those limitations, DNA analysis is incredibly powerful. Labs compare whatever genetic material they can extract against massive reference databases. If there's a match, say, to a bear, deer, or a human, that's a strong identification. If there's no clear match, things get more complicated. The sample might be degraded, the database might be incomplete, or, in rare cases, the result might be something unusual. That last possibility is what keeps the mystery alive. After sending the sample in, the waiting game began. And honestly, that's the hardest part. Your imagination starts filling in the gaps. If you're hoping for something extraordinary, every delay feels dramatic. If you just want answers, each email from the lab feels like a countdown. The lab's process is methodical. First, they check if the sample is even usable. Is there enough material? Is it contaminated? Can DNA be extracted at all? If so, they amplify whatever fragments they find and compare them against known sequences. It's not flashy, it's careful, technical work. And when the result finally comes in, it's usually not some cinematic reveal. It's a straightforward, scientific answer. In this case, the DNA matched a known animal species, not some unknown primate. In plain terms, the hair didn't belong to a or creature. It came from something far more ordinary. That might sound a little underwhelming, but from a scientific standpoint, it's actually the best possible outcome. The test worked. It replaced speculation with evidence. And that's exactly what science is supposed to do. This result isn't unusual either. Most so-called Bigfoot hair samples end up belonging to common animals: bears, deer, horses, dogs, or even humans. Sometimes the DNA is too degraded to say much beyond. It's from a mammal. But when the sample is good enough, the answer is almost always something familiar. So why does belief in Bigfoot stick around? Part of it comes down to how our minds work. Humans are natural pattern seekers. We connect dots, fill in gaps, and build stories, especially in settings that already feel mysterious, like dense forests or isolated trails. A shadow becomes a figure. A sound becomes movement. A clue becomes a narrative. There's also an important distinction here. Science can tell you what a sample is, but it can't always explain how it got there. Finding deer hair on a branch doesn't explain what someone thought they saw nearby. Identifying bear DNA doesn't automatically disprove every Bigfoot sighting. It just means that specific piece of evidence isn't linked to anything unknown. And that distinction matters more than people think. At its core, this experiment shows how science actually works. It doesn't start with certainty, it starts with a question. Then it tests that question using the best tools available. Sometimes the answers are exciting. Often they're not. But those boring answers are what keep everything grounded in reality. If someone claims they've found Bigfoot hair, DNA testing gives us a way to check. If the result points to a known animal, the mystery shrinks. If the result is inconclusive, it doesn't confirm anything extraordinary, it just means the sample wasn't good enough.
So, if you love this story, please like and subscribe. See you in the next video.